Hi, this is Dr. Green, and we are looking at an example for project number 3 and problem number 5. So this example is what's called a factorial ANOVA or two-way ANOVA. So we have two independent variables here in this problem, type of lighting and light intensity. And what we're doing is we're doing some phototherapy on newborn infants that have been born jaundiced. So their liver is not taking bilirubin out of the bloodstream fast enough, so it's very typical for them to do treatment. So what's in the table here are the mean drops in the bilirubin levels in 24 randomly selected infants after 7 days of therapy. So for example here, where they use fluorescent type lighting, and at low intensity there were 4 infants in that group, and the drops were 8, 7, 9, and 6. And then fluorescent with medium intensity, the drops in bilirubin were 10, 9, 12, and 10, etc. And then the LED group, we call that group 2. At low intensity, the drops were 6, 8, 9, 7. And then for medium intensity, 12, 14, 13, 14, and then here for high intensity. So that is the data. And they ask us in this problem to perform a two-way analysis of variance and explain the results, and show all your work to receive full credit. And then they want us to find the effect size for each one of the factors and for the interaction, and then explain the results. So what's going on here with a two-way ANOVA is that the lighting type could have an effect on how much the bilirubin level goes down, but also the intensity of the light could have an effect on how much the bilirubin goes down. And we kind of see that from low to medium to high, we can kind of see that the numbers are getting bigger. It's a little tougher maybe to see between, the fluorescent group and the LED group, this group and this group, whether there's a difference. But that's what we're going to analyze. And then there may be some combination effect, and that's what's called the interaction. So here are the SPSS steps to set up the data, and let me go through that with you. But first, let me tell you, there are, because there are 2 factors here, there are actually 3 hypotheses that we're going to be testing all at the same time. So if the first one is for light type. The null hypothesis is light type has no significant effect on the bilirubin. Alternative is that it does have a significant effect. For light intensity, the intensity does not have a significant effect. That's your null for the second hypothesis test. Or it does have a significant effect. That's the alternative. And then the third hypothesis has to deal with intensity by type interaction, is how you say that. So the combination of intensity and type either does not have a significant effect, or it does have a significant effect. So we're testing all of those things at the same time, and we're going to try and sort out what's going on. So the first thing that we have to do is we have to prepare our data set. So I've already entered the data into SPSS. Let me show you how the data set is set up here. So here's our data set, and I've got a lot of variables in here. So let me kind of tell you what's going on first. So we want to pay attention to these first 3 variables to start with. So I've got a variable for light type, and then I've got that coded in here as 1 for fluorescent and 2 for LED. And then I've got a variable for intensity, and there are 3 levels of intensity, so you have to code 1 for low, 2 for medium, and 3 for high. And then for the bilirubin decrease, that doesn't need to be coded. And all of those are scale variables. In fact, everything we use is going to be a scale variable. So let's just pay attention to those first 3 variables. So this is the original data table here. So let's take a look at that. Go back up here. So we had fluorescent and low, so that's 1 for light type and type 1 for intensity, and that was 8796. So 1 for type, 1 for intensity, 8796. And then next we had LED, which is type 2 light and type 1 low intensity. So this is 4 2s and then 4 1s, and that's 6897. So that's 6897 here. So I coded those rows. And then I did the next column, which is 1 and 2, got 4 of those, and then 2 and 2, I've got 4 of those. So 1 and 2, 2 and 2, that's 1 and 2, that's that data there. So that is this data here. And then 2 and 2, 2 for type and 2 for intensity, is that data there, which is this data here. And then I did 1 for type, 3 for intensity, 2 for type, and 3 for intensity. And that is this data here. So that's the last column of data. So that's how we coded that in. So once you've got that data coded in, then we want to do our analysis. So we're just paying attention to these first 3 columns. So we are going to do analyze, general linear model, and univariate. And then you'll get this dialog box. And we're just dealing with these first 3 here. Our dependents are type and intensity. So take those and move them over as fixed factor. And then our dependent is the bilirubin decrease. Next, you're going to click on plots, and you'll get this dialog box. And there are only 2 types, and type is going to go under separate lines, and then there's 3 types of intensity. That's going to go on our horizontal axis. So this is going to draw the interaction plot. Now after you've selected those, remember to hit add and then continue. Then under post hoc, click that, and you'll get this dialog box. And we wouldn't do any post hoc for type because there's only 2 levels. So take intensity, move that over to post hoc. So if there's differences in intensity, we can analyze that with Tukey. So make sure that Tukey is checked and press continue. And then under options, click on that. You will get this dialog box. We're going to move all of these variables over. Is display means for. We're going to do compare main effects, and then let's also click descriptive statistics and then click continue. So that's the setup. Now we may not need all this information, but better to have more than we need and say, oh, we only need this and we'll bring it over, than to not have enough and have to go back and run everything again. So after you're done there, click OK. And then it takes you to the output window. It's generated all of our output. So let's go ahead and move this over. And let's go ahead and look at our output here. Okay, so it did a univariate analysis here. It's just listing, there were fluorescent, there were 12 entries. LED, there were 12 entries. For low, medium, and high, there were 8 entries each, a total of 24. By the way, yours end up being 15, 15, and 10, 10, 10, because you've got 5 subjects in each group, whereas I did this with 4 subjects. So your table will be slightly different. Descriptive statistics, so for fluorescent light with low, medium, and high, it's telling us what the mean drop in bilirubin was. And then we can see LED light for low, medium, and high, and then the total. So notice that for LED and fluorescent low, that the means are exactly the same, so they're not going to be statistically different. But here we're seeing a 10.25 at medium, and here at 13.25, so it's higher for LED, and 13.75 for high, and 16.50, so that's again higher drop in bilirubin for the LED light. So it looks like LED is more effective. So that's where that can be helpful. And then the test of between subject effects, this is where stuff really starts going on. So take that table and copy it and bring that over to your report. Okay, and I've already brought that over. And so let's analyze this a little bit. The first two rows, corrected model and intercept, ignore those rows. Okay, the next three rows, so this is testing, is our type of light, is that significant? And I've highlighted this, the p-value is 0.001. Remember, significance means p-value, so that is significant. Intensity, that's also significant. P-value is less than 0.001. And then the combination of type and intensity, that's also significant with a p-value that's less than 0.05. So all three of these guys are significant. So we can state here that there is a significant main effect for light type. P is less than 0.05. There's a significant main effect for light intensity. P is less than 0.05. And then there's a significant interaction for intensity and light. P is less than 0.05. So if there was no significant interaction, then we would have a different analysis to do. But since there is a significant interaction, we're not going to do the main effect tests, which would be testing to see if just light type alone, independent of intensity, makes a difference, and just intensity independent of light type makes a difference. Instead, we're going to do what are called simple main effect tests here. And those are hypothesis tests where you hold one variable fixed and then you let the other one vary and see what happens. So the two possibilities here to analyze this are going to be that you hold light type fixed and let intensity vary, or hold intensity fixed and let light type vary, and analyze those. And the significant interaction, one way to explain that is that the significant interaction means it depends. So we ask, is there a significant effect of light intensity on the bilirubin? Well, it depends. We have to look into it a little bit more to see how that varies with light type, because there's an interaction. Is there a significant effect of light type? Well, it depends. We have to look and see what the interaction is with intensity to see how things vary. So we have to do some more work when we have an interaction. We have to do these simple main effect tests. Now, the next thing that we're going to use from our SPSS output here, so we're not going to use the pairwise comparisons for fluorescent and LED alone. Those are main effect tests. We've got an interaction. We're also not going to use intensity, and we're not going to use the pairwise comparisons. Those would be for main effect tests. And we're also not going to use the post hoc test, multiple comparisons. This is very similar to the pairwise comparison table up above. So the next thing that we're going to use is the profile plot here. Okay, so let's take that and let's bring that over to the report, and then we'll analyze it. So notice here before we bring it over, because it does not come over in color, LED here is the top line green and fluorescent is the bottom blue. So let's go ahead and bring that over. Okay, and no, I'm sorry, I did bring over colors. Okay, so that's this interaction plot, and it's trying to show us the interaction between the two factors here. So notice that fluorescent light alone, as intensity increases, then this is the mean drop in bilirubin on the vertical, and we've got low, medium, and high intensity. So as intensity increases, we can see that bilirubin levels decrease. Well, the amount of bilirubin that's cleared increases. And then the same thing for just LED, the amount of bilirubin cleared from the body increases. But notice here that they're not statistically different at low intensity, but they might be statistically different at medium intensity and high intensity. So that's one thing we've got to analyze. And then also, we see that the amount of bilirubin cleared from the body is increasing for the blue fluorescent and increasing for the green LED. But we want to know, from baseline to medium to high, is that significant? And then the same for the LED light. So we want to answer two questions here. So these are our simple main effect tests. So we want to compare the 3 intensity means for each type of light. Okay, so we're going to compare these 2 means for high, and these 2 means for medium, and these 2 for low. Well, we know those aren't statistically different. But then we're also going to compare the type means for, let's see, we're going to compare the intensity means for each type, and then we're going to compare the type means for each intensity. So I'm sorry. So the first one here, compare the 3 intensity means for each type. So we pick fluorescent type, that's the blue, and compare those 3 means. Comparing 3 means, that's going to be a one-way ANOVA. And then for the LED, we want to compare these 3 means here, going across, and see how are they related. That's going to be another ANOVA. And then compare the type means for each intensity. So that's here, if we go down, for low intensity, compare the 2 different means, blue to green. For medium intensity, compare the means blue to green, and for high, and see if they're statistically different. Okay, so those are the 2 simple main effect tests that we need to do, is do those 2 comparisons. And this interaction plot gives us some kind of idea of what's going on. And we're seeing an interaction here. They say in your book that there's an interaction when they cross. Okay, well, these 2 guys cross here. Okay, if you kept the lines, if you extended the lines, they would cross at that point. So that's seeing your significant interaction. So now we've got to set up these ANOVAs. Let's answer this first question here. Compare the 3 intensities for each type. Okay, so let's go back to our data table here. So now what we're going to do is we're going to look at the next 2 variables here, which are going to be the intensity levels for fluorescent lighting and the bilirubin levels for fluorescent lighting. So for fluorescent lighting, I've got through the 3 intensities, low, medium, high. So we're going to concentrate on those 2. And then we're also going to do the same thing for LED. So we're going to look at the intensity levels for LED. This is the group variable, low, medium, high. And then we are going to look at the bilirubin drops. Okay, so intensity for fluorescent, that's a grouping variable, and intensity for LED, that's a grouping variable. And then these are the bilirubin levels that go with them. I'm sorry, let's see, Billy for fluorescent and Billy for LED. So those are going to be our 2 ANOVAs. So if we go back to the data here, that's going to be the first 3 columns were the 2-way ANOVA. So now we're looking at the next. These 2 columns will be 1 ANOVA for fluorescent to see how low, medium to high, see if those are statistically different. And then these 2 will be another ANOVA for LED lights, low, medium to high, to see if those are different. So we're going to do 2 ANOVAs here. So we're going to do analyze, and we're going to do compare means, and then one-way ANOVA. And then first we're going to analyze intensity for fluorescent is our factor. Bilirubin for fluorescent is our dependent. We are going to click, we don't need, let's see here. We do need post hoc here. We're going to do Tukey, continue, and OK. And that generated an ANOVA and multiple comparisons. Let's go back and do the other one. So let's do an analyze. Oh, I'm sorry. I should also tell you how I set the data up here. So first of all, let's look at intensity and bilirubin for fluorescent. So this is just the fluorescent data is what I did here. So if we go back to the original table of data here, I'm looking at just the fluorescent data. So I'm just looking at these values here, those 12 values. For you, there'll be 15. So I had to code my intensity as 1, 2, or 3, and then I had these 4 values, these 4, and these 4 in order. So I've coded here 4 1s, and 4 2s, and 4 3s, and then these are the low intensity data, the medium intensity data for fluorescent, and then the high intensity data for fluorescent. And then I did the same thing for the LED. So I coded in those 12 values, 1, 2, and 3. So for intensity, I've got 4 1s. You're going to have 5 at a time instead of 4. 4 2s and 4 3s. And then I coded in these data here. So those you can actually copy and paste from the first 3 columns if you want to, or just re-enter them in. Okay, so let's do our second ANOVA, which is intensity LED, bilirubin LED. So seeing how for LED lights the things vary. So analyze, compare means, and one-way ANOVA. And now instead of bilirubin fluorescent and intensity fluorescent, we are going to do intensity LED as our factor, bilirubin LED as our dependent. Post hoc is set again to do Tukey, and we're going to click OK. All right, so we're going to go ahead and take both of these ANOVA tables over. So I've got, we won't need, let's see, we'll need multiple comparison there, and that ANOVA, that is for LED. That's the last pair, and then back up. And then these multiple comparisons, and this ANOVA is for the fluorescent. And you can see fluorescent there. So we bring those 2 over, and let's analyze those. So I brought those 2 tables over, and that's here is the first ANOVA, and that is for all fluorescent lighting, low to medium to high. Notice the significance level is 0, so there is a statistical difference. And then we want to see, well, you know, they look like they were going up on the main effect, or I'm sorry, on the interaction chart here. They look like, you know, fluorescent is what we're analyzing. Looks like these are going up, but is it statistically significant from low to medium and from medium to high? That's what we need to know. So that's what the multiple comparisons, Tukey, is going to tell us. So we're looking here. I'm looking for the positive I minus j values. So here I've got from median to low, significance is less than 0.05. From high minus low gives a positive value, it is significant, and high minus medium gives a positive difference and it's significant. So high is bigger than low is bigger than, I'm sorry, high is bigger than medium is bigger than low, which is what it looks like on the interaction chart. So here's how you'd summarize that information. So for fluorescent type, the bilirubin levels were significantly different. That's what the ANOVA showed. F of 29 is 28.26. That is this value here. And the 2 and the 9 are your degrees of freedom numerator denominator. So that shows they're different, and P was less than 0.05. And then higher intensity decreased bilirubin more. Okay, so the decreased values were larger, and that was from Tukey's honestly significant difference. That's right here. Okay, then we did the ANOVA, so I brought the ANOVA and the multiple comparisons over for LED here. And what we see is that we've got a significant ANOVA again. So the differences are significant. So again, there what we're doing is we're looking at the green and we're saying from here to here and here to here, is it significant? Okay, well, we look at Tukey. It is significant. The ANOVA says it's significant, but look at Tukey and we can see which pairs are different. So we're looking for the positive differences. I see a medium minus low. That's significantly different. And high minus low is positive difference, it's significant, and high minus medium is positive and significant. So again, high is bigger than, medium is bigger than low. So same thing goes on here. For LED, bilirubin levels were significantly different. F of 29 is 58.64, and that's the F value right there. And then P was less than 0.05, and higher intensity decreased bilirubin significantly more, and that's by Tukey, what we saw here. Okay, so far we've established in the interaction plot that these differences on the blue line alone for that one type, fluorescent, are significant, and these differences on the green line alone for LED are significant. Now we've got to look at just for low intensity. Well, this is not going to be significant, but for medium intensity, are those means significantly different? And for high, are those significantly different? So for those, we've got to do that's only 2 groups. We just do a t-test. We just do a 2-sample t-test. So to do that, we've got to look at just the low data, just the medium data, and just the high data. So if we go back to our data set here, we've got to look at just the low data, so just those 8 values, do a t-test. Just these 8 values, do a t-test, 2-sample, and just these 8 values. So I'm going to code those in as 4 1s and 4 2s, and then this data. 4 1s and 4 2s, this data. 4 1s and 4 2s, this data. So there's going to be 3 t-tests. So there's going to be 3 times 2, 6 more columns of data. So let's go back to the data here. Okay, and now we are looking at, so we're finished with these 4 columns. And we are looking at, I labeled, so I added 6 more variables. The type for low intensity, so the type of light for low intensity, and the bilirubin for low, the type of light for medium intensity, and the bili for medium, and type of light for high intensity, and the bili for high. So I did 4 1s and 4 1s and 4 2s. So that's fluorescent and LED. And then this data here is the low intensity data. That is these numbers here. Okay, and then I did the same thing over here for medium. 4 1s and then 4 2s. Whoops. And then I did the medium data here. So that is this data. And then I did the same for the high data over here. So now we got to run 3 t-tests. So let's go ahead and run those t-tests. So this is going to be analyze, compare means, and it's going to be independent samples t-test. And we'll go ahead and move the variables over. So you got to do one at a time. So we are going to do type for low as our grouping variable, and bili low is our test variable. Now for your grouping variable, got to define groups. Group 1 we called 1, and group 2 we coded as 2. Click continue. Click OK. Okay, so here's our independent sample t-test for low. And now we'll go back and we'll do it again here for the medium. So we're going to do analyze, compare mean, independent t-test. And now instead of for low and low, we're going to do medium, medium. So take our low, bring it over. We're going to do bili medium. And we're going to take out our low here, and we're going to do type for medium. Okay, and groups are already defined for us. Click OK. And here's our second independent samples t-table. And now we're going to do one more time. So we're going to do analyze, compare means. Oops, I need to bring that down. We're doing analyze, compare means, and independent sample t-test. And now instead of medium, we are doing high. And here instead of medium, we are doing the type for high. Okay, groups are defined already the same, 1 and 2. Click OK. And then there's our last independent sample t-test. So you've got 3 t-test tables, 3 t-tables. Okay, 3 of them. Bring all 3 of those over back to the document. Okay, so that is after our ANOVAs, and that's here. So here's the independent sample t-test, and this is for low. And what we see is that the t-value here is 0, so there is a significant, there's no significant difference. Okay, so at low intensity, bilirubin levels were not significantly higher for LED type. P was greater than 0.05. Brought the next t-table over. And to make these fit a little nicer, I deleted the last 2 columns off for the confidence interval because we don't need those. Because remember, this table is too wide to get on the page. So if the last 2 columns go off, no big deal. Now for medium, we analyze the two types for medium intensity, and here we see that the significance is 0.009. That's less than 0.05, and our t-value is big. So at medium intensity, bilirubin levels were significantly higher for the LED. Okay, and that's what this is testing. We can go back and we can look at the means. The mean for LED was higher than the mean for fluorescent. So it's actually a one-tailed test. And remember that you state your t-value with degrees of freedom. That 6 is right here. And then your test statistic is highlighted right here. And then our p-value is less than 0.05. And then in the same way, that last table, you bring that over. That's going to do, for high intensity, it's going to test fluorescent versus LED light. We see a p-value that's less than 0.05, and our test statistic there, degrees of freedom, still 6. So at high intensity, bilirubin levels were significantly higher. The decreases were significantly higher for LED type again. List your t-value, test statistic, p less than 0.05. Okay, so here's our APA summary, okay, which is basically telling what's going on in this chart. What we saw is that this difference, blue to green, is not significant, but this difference, blue to green, is, and this difference, blue to green, is, with LED being significantly higher. So here's our APA summary of everything that's gone on. So we did a two-way between subjects ANOVA, and it showed significant main effects, and state your F value, your F statistic, and P less than 0.05. So that's the first ANOVA table. And that was for type and also for intensity. The F value, degrees of freedom, and P less than 0.05, and a significant intensity versus type interaction, F value statistic, P less than 0.05. So that's our very first table here. And here's our first F statistic, our second one for type, intensity, and intensity versus type, third F statistic, and then all our p-values were less than 0.05. So that's that part. And then since there was a significant interaction, that meant that we had to do the simple main effect test. That was the 2 ANOVAs and the 3 t-tests. So, and they indicated that for each light type that we had, higher light intensity, the higher the light intensity, the lower the bilirubin levels. Or actually, I should say the greater, we should actually say the greater the bilirubin decrease levels, since it's decrease in bilirubin here. There we go. So, and if you can spell greater right, you'll be doing good too. There we go. So the greater the bilirubin decrease. So, and that we saw with the Tukey HSD. So that's the significant differences for the 2 ANOVAs. Okay, so that was this first ANOVA. P less than 0.05 says it's significantly different. And then the Tukey ordered them. Okay, now for fluorescent lights here, intensity, higher intensity, decreased bilirubin more. So higher decreased values. And then also here for LED light, it was also significant. And again, higher intensity, decreased bilirubin more, so higher decrease levels. Okay, so that is this statement here. That's the 2 ANOVAs. It summarizes the 2 ANOVAs. And then bilirubin levels by light type, they were not significantly different at low intensity. That's the first T table. It was not significant. Right here, p-value was 1. P was greater than 0.05, not significant. But at medium and at high, they were significant. So, but they were significantly higher for LED at medium intensity here. List your T value, and the P was less than 0.05. Okay, that's from up above. And then also at high intensity, and this test statistic in P less than 0.05, that's right here. So I just pulled those down. So that's our complete summary. That's a whole project all in itself. Okay, so you will need to do the same thing. One two-way ANOVA. Okay, you're going to have the same thing that happened here. You're going to have both effects are significant and a significant interaction. And because of the significant interaction, you want to look at your plot, and that'll give you an idea of what you're going to try to show in your 2 ANOVAs and your 3 t-tests. So you'll have to do the exact same thing, 2 ANOVAs and 3 t-tests. And then to finish up, if Part A wasn't enough, they have a Part B on here, which was to estimate the effect size. Well, the effect size is eta squared. So we want to do eta squared for type of light, eta squared for intensity, and eta squared for intensity by type. And for each one of those eta squareds, it's the sum of squares value divided by the sum of squares total. And these are all values that are in that very first ANOVA. So sum of squared by type, sum of squared total, 22042 divided by 291. And those are in this very first ANOVA here. Okay, and I've got them highlighted in green. So to get eta squared for type, you do 22.042 divided by, and we're using corrected total here. Okay, make sure you use the corrected total and not this total, because that includes these 2 rows that we left out. So, and then we do 233 divided by 291, and then 11 divided by 291. So those are your eta squared ratios. And those are these guys here. And they give you 8%, 80%, and 4% to 2 decimal places, which is what they asked for. And then they say interpret them. So eta squared for type is 8%. That means that 8% of the variability in the bilirubin levels there is explained by the type of light that the infants were exposed to during their therapy. Eta squared for intensity is saying that 80% of the variability in their bilirubin levels was explained by the exposure level that the infants were under during the phototherapy. And then the 4% here is saying 4% of the variability in the bilirubin levels is explained by the combination of intensity and type. And then here's how I'll grade for this problem. I'll do 5 points for the SPSS two-way ANOVA and interaction plot. So those are the only things you're going to bring over out of that first test. You got a lot of tables there. Just bring over the two-way ANOVA table and the interaction plot. 5 points for the simple main effect ANOVAs and the t-test SPSS output. Okay, so 2 ANOVAs, 3 t-tests. So just bring those outputs over. And then 5 points for your statement of, your hypothesis, test values, and then the APA summary. And then the last 5 points is going to be for computing and interpreting your effect size, which is what we did here. So hopefully that helps out a lot on this example. It's a super complicated example. I don't know why they did one that was this complicated for the project that's due the very last day class. But in any case, I hope this helps. I am also going to attach my file for you here. Okay, my data file. So this file, I'm gonna let you have a copy of that so you can see how that's constructed and refer back to it. And you might be able to I think you can just edit this file and just overtype it. The only thing is these go in groups of 4 1s and 4 2s and 4 3s, etc. You've got 5 in each group of combination of 2 factors. So you're going to have 5 1s, 5 2s, 5 3s, etc. Okay, but it'll have the same basic setup. You'll have the same number of variables and the same type of variables.